So for 10i electrical safety, there's not actually a lot in terms of what we can write. More of it is about actually looking at the plug. And obviously in the UK we use a 3-pin plug. So you have the top pin and then you have 2 pins at the bottom. What we're going to do here is actually look at what do each of those pins do. What do they represent? What's going into those pins? So as you'll see, there are 3 different wires, although 2 of them should really be going through these 2 sections here and then 1 at the top. If we were to wire the plug, you have 1, 2, 3 wires. This one, number 1, has a fuse attached to it. This one is a brown wire, which is the live wire. So 3 wires, brown, blue, and then 1 which is a mixed green-yellow. The brown wire is the live wire. You need to explicitly know the brown wire is the live wire. The blue wire is the neutral wire, and the greeny-yellow wire is what we call the earth wire. Now, going back here, the fuse, most people have heard of a fuse in general, but we'll look specifically at it in a minute. But the fuse is always connected to the live wire. The live wire is very high voltage. It's the wire that is bringing the electricity from the power station across the national grid and into your home through your device. The live wire is transferring that electrical energy with all the energy in there to your home. Okay, so it's the dangerous wire. It's high voltage. The fuse is going to be there, which we'll look at in a second, to keep that plug safe in one respect. Neutral wire is simply once the energy's been transferred, the electrical energy's been used up, that neutral wire will just take your current, your electricity back to the power station and close the circuit essentially, but at low 0 voltage. So very little danger, it just simply completes the circuit, so the electrical energy is transferred, it's used, and then obviously it goes back to pick up more energy. The green and yellow earth wire specifically is there for safety. So this green and yellow earth wire is the 3rd wire in a British plug, and the way that this works is it also has 0 volts, but it is only there to transfer any electrical current that is not going through the normal circuit. So for example, if the live wire breaks in an appliance, generally if the appliance is a metal appliance like a toaster or even a microwave, anything that you know that is an appliance that uses electricity, that is made of metal on the outside, if this live wire were to break and come into contact with the metal casing, you know, because metal is such a good conductor of electricity, the whole appliance is going to become charged. Now, if you're walking up to the toaster, let's say it's the toaster, there's a faulty wire in the toaster, the live wire has touched the outside casing of the toaster, all the electricity that's coming from the power station through the live wire, the brown wire, it's all charging my toaster, but you can't see it. You cannot see a charged object. Now you walk over, you go to touch your toaster, you are personally creating a closed circuit between the toaster and the earth. And electricity will take that path through you into the ground, discharge itself in the ground, but as you're there in the middle, you're going to be electrocuted. All that energy, all that current that passes through is going to electrocute you. And the amount of current obviously will determine how dangerous and how bad the electrocution is. So, if I don't know if there's a faulty wire and I can't see that the live wire has charged my toaster, how do I know that it's safe? The earth wire, green and yellow wire, 0 volts, is connected to the plug, but there should be a connection on the appliance itself that connects to the earth wire. So if the live wire touches the component, the device, the metal gets charged, but then the earth wire, 0 volts, very low resistance, because obviously if it's low resistance, it will take all the current, a lot of current will flow. If the outer casing starts to become charged, that charge will not sit on the device. It will travel straight down the earth wire and it will discharge through the earth wire back to the power station, for example, instead of building up on the appliance and waiting to be touched and complete the circuit through a human to the ground. So an earth wire is a safety wire. Low resistance, so that if the current gets too high on the appliance, it goes straight through the low resistance earth wire. And it's there literally to complete a circuit from the device back to the power station without charging the object and becoming a danger and causing electrocution. So the earth wire, green, yellow, neutral, blue, live, brown, high voltage, connect the fuse to the live. Here is the symbol for a fuse. It's like a resistor but with a line that goes straight through. And essentially what it is you see a little glass casing, usually with metal ends, obviously to complete the connection and the circuit, and it has a small thin wire that passes through. Now what happens? If the electricity that's passing through the live wire gets too high, then we're talking about a dangerous circuit. Because we know when electricity is transferred from one place to another, the resistance in any wire generates thermal energy. Now if a fuse wire is so thin, it will generate more thermal energy, and if the current gets too high through the fuse, then that thermal energy will actually melt the fuse. Now if you melt the fuse and it breaks the fuse, there is no longer a complete circuit, no more current will flow through this live wire. So a fuse is there specifically if the current gets too high, the fuse, it generates too much heat, it melts the fuse, it breaks the circuit, it stops the current. Okay, that's what the fuse is there for. The problem with that is once it's broken, you have to replace the fuse. So if a fuse gets blown, you have to go in, you have to open up all the electronics, you have to take out the fuse and replace it with a new one. Okay, a circuit breaker specifically gets rid of all that nonsense and all that messing around. A circuit breaker in the home, if you've ever had electricity or the power go out in your house before, you probably had to go to the electricity box. You've got 50 different sockets, switches that were all obviously on, and you'll see one that flicked off. That's a circuit breaker. The one that flicked off was there specifically because too much current was going through the circuit at that time. A circuit breaker senses that too much current is going through. It switches off the switch itself. So all you need to do is manually go back to the circuit breaker, switch it back on, and then your current will flow again. There's no need to keep replacing a circuit breaker. You just switch up if it switches itself off. Okay, so a circuit breaker is there again as a safety feature, but you can use it multiple times. You don't just have to keep replacing it every time the fuse melts. Okay.